Good morning everyone. Today my topic is about total probability theorem with proof. This is the PPT of PTSP subject. I am G Naresh from ECB section. So let's get into the topic. Introduction. Probability is the likelihood of an event. The probability of an event going to be happen is 1 and the probability of an impossible event is 0. In probability theory, there exists a fundamental rule that relates to the marginal probability and the conditional probability, which is called the formula or the law of total probability. Through several distinct events, it expresses the total probability of an event. So the law of total probability theorem is for two events A and B associated with the sample space S, the sample space can be divided into set of A intersection B bar and A intersection B and A bar intersection B, A bar intersection B bar. This set is said to be mutually disjoint or pairwise disjoint because any pair of set is in disjoint. Elements of this set are better known as partition of the sample space. This can be represented by the Venn diagram as shown below. In case where the probability of occurrence of one event depends on the occurrence of other event, we use the law of total probability theorem. So when the probability of one event depends on the probability of other event, law of probability total probability is used. This is the Venn diagram. So here event A and event B is represented as circles in the sample space, and A intersection B bar is the yellow color part and A intersection B is the green color part, where events A and B are same, and the blue color part is the B intersection A bar, and A bar intersection B bar is the sample space. Other than this, A intersection B bar and A bar intersection B and A intersection B. Law of total probability statement. Let events C1, C2, C3 and so on Cn form partitions of the sample space S, where all the events have a non-zero probability of occurrence. For any event A associated with S, according to the total probability theorem, the statement is P of A is equals to P of A is equals to summation k is equals to 0 to n P of Ck into P of A by Ck. Venn diagram. Here we have taken events C1, C2, so on Cn. So this C1, C2, so on Cn is represented in the sample space in the Venn diagram. Total probability theorem proof. From the above mentioned Venn diagram, C1, C2, so on Cn is the partitions of the sample space S, such that Ci intersection Ck is equals to pi, where I not equals to k and I and k is equals to 1, 2, 3, so on n. That means it is a positive number. Also, all the events C1, C2 and so on Cn have non-zero probability. Sample space can be given as S equals to C1 union C2 union so on Cn. So here S sample space S is equals to the addition of all the events C1, C2, C3 union of all the events. For any event A is equals to A intersection S. So A becomes A intersection of S. We have already know that S value is C1 union C2 union C3 so on Cn. So that substituting S, then A becomes A is equals to A intersection of C1 union C2 so on Cn. From this A intersection C1 union A intersection C2 union so on A intersection Cn. Let it be equation number 1. We get that A intersection Ci and A intersection Ck are the subset of Ci and Ck. Here Ci and Ck are disjoint of I and K. Since they have mutually independent events, which implies that A intersection Ci and A intersection Ck are also disjoint for all I not equals to K. Thus, P of A is equals to P of A intersection Ci union P of A intersection C2 union so on P of. So here P of A intersection C1 plus P of A intersection C2 plus so on P of A intersection Cn is equation 2. We get P of A intersection Ci is equals to P of Ci into P of A by Ci by conditional probability. So by using 2 and 3, 1 represented as P of A is equals to P of C1 into P of A by C1 plus similarly P of A intersection C2 can be written as P of C2 into P of A by C2, and similarly P of A intersection C3 can be written as P of C3 into P of A by C3 plus so on P of Cn into P of A by Cn. Instead of writing P of C1 into P of A by C1 plus P of C2 into P of A by C2 plus P of C3 into P of A by C3 plus so on P of C1 in Cn into P of A by Cn, we can write as integration summation k is equals to 0 to n P of Ck into P of A by Ck, where k is 0 to n. So the statement of total probability theorem is P of A is equals to summation k is equals to 0 to n P of Ck into P of A by Ck. Hence proven. Thank you.